Hi, I'm John Paul Martin, the Warning Coordination Meteorologist with NOAA's National Weather Service in Bismarck, encouraging you to attend skywarn spotting in your community when the National Weather Service comes out for that, or viewing severe weather safety online at National Weather Service website, or through videos like this. National Weather Service website, www.weather.gov. And it'll suck here. See these pieces of cloud over here on the left? They're being sucked into the thunderstorm. See it right there? That's a rotating thunderstorm. We call that, if it forms, extended on a beaver's tail. It's called a beaver's tail. Kind of looks like a back end of a beaver cloud. All right. Again, this is in the handout material. So here's our supercell thunderstorm. Here's the downdraft, the downward moving air. That's where it's raining, maybe some hail. That's where your shelf cloud would be found. And then it would move out from under there, race out ahead of the thunderstorm, like in that video. Here's the updraft, the air that's moving upward in the thunderstorm. This bottom of the thunderstorm, remember I said that sometimes, well, a lot of times, you can see daylight through the bottom of the storm. You can see daylight. That's called the rain-free base. It's the base because it's the bottom of the thunderstorm, rain-free because there's very little, if any, rain falling out there. So the rain-free base of the thunderstorm. Sometimes a little piece of the rain-free base, see it right here. Sometimes a little piece of the rain-free base will drop down and form what's called a wall cloud. That's a lowering of the rain-free base right there. And sometimes out of a wall cloud you can get a tornado. Now, you don't need a wall cloud to get a tornado. You don't really need a wall cloud to get a tornado. And you do not need a supercell thunderstorm to get a tornado. Tornadoes can form anywhere in the thunderstorm, and they can form out of any thunderstorm. But most of them come from supercell thunderstorms. Most of them come from wall clouds. But nothing is always or never. Anvil, you've all heard of the anvil part of the thunderstorm. That's that, looks like that, the big metal anvil, white on the top, narrows, and then white on the bottom. That's this cloud. We've got a picture of it coming up. And then an overshooting top. Overshooting top is when the updraft is so strong here, the upward motion is so strong it actually broke through the anvil, and it's a bubble of cloud on the top. We've got a picture coming upstairs for you. Let's go over this real quick. How do we get a thunderstorm to start rotating? How does that happen? Why does this thunderstorm rotate and that one does not? Well, in the atmosphere, you have wind from different directions as you go up through the atmosphere. Sometimes the wind may all be from this direction as you go up. Sometimes the wind at the low layers will be from this way, here they're from that direction, here they're that way. They might be at 20 miles an hour here, 40 miles an hour up here, 80 miles an hour up here. All right? So when you get wind from different directions, wind changing direction as you go up through the atmosphere, or wind changing speed as you go up through the atmosphere, that's called wind shear. Any pilots? A pilot wants to know about wind shear. It's very critical to aviation. They actually have on airplanes, at least on commercial airplanes, wind shear detection devices. Okay, very, very critical to airline operations, wind shear. So for example, we have the wind blowing this way at this level, this way up here, and this way high up. So if I'm a parcel of air, the wind's pushing me this way. Now I get higher up, the wind is pushing me this way. Now I get higher up, the wind is pushing me this way, and eventually, this parcel of air starts rotating. This thunderstorm starts rotating, starts spinning. A rotating thunderstorm, you're on your way to getting a tornado. Not always, but if you can get that thunderstorm to start rotating, now it's easier to get that thunderstorm to put down a tornado. Not always will you get one, but it's easier. In the atmosphere, there are these horizontal rolls. You can't see them, but when the wind is blowing, you know, the wind is blowing a little faster here than it is here. So you start getting these rolls. And on one of these horizontal rolls, you can't see it with your eyes, but they're happening. When you get one of these to run into a thunderstorm, the thunderstorm has an updraft and a downdraft. So that horizontal roll is turned vertically. It's pulled up by the updraft. It's pulled down by the downdraft. Now you get a tornado. That's how a tornado forms. So you get this horizontal roll. It runs into a thunderstorm, and it's stretched up and down. Up into the thunderstorm, down toward the ground. Tornado. You might look out the window and see this. Say, holy cow, looks like a flying saucer. It's a mesocyclone, a rotating updraft, a supercell thunderstorm. The most dangerous kind of thunderstorm you can have. Now, are you guaranteed you're going to get huge hail? No. Are you going to get a flash flood? Not necessarily. Are you going to get a tornado? Not necessarily. But the chance of getting all those things is increased. The chance is and you may not get it, but your neighbor a mile down the road might get it. The other thing about warnings, remember that if we issue a warning for your area and you don't get severe weather, be thankful that it skipped over you. But I'll bet you your neighbor, or 2 neighbors, or 4 neighbors, or 8 neighbors down the line, you know, the next farm or the next farm after that, they may have gone it. This lowering of the rain-free base, this little square, almost like a little square under the thunderstorm, and it's attached to the thunderstorm, is called the wall cloud. The wall cloud. Now we have to be careful with our shelf cloud and our wall cloud, because a lot of times people will see a shelf cloud, which means what? My wind's going to change direction, it's going to increase in speed, but it doesn't mean there's a tornado. Right? The difference between that and a wall cloud, that means, man, I'm setting up to put out a tornado. Not guaranteed I'm going to put it out, but once you get a wall cloud, your next step would be for the wall cloud to start rotating, and then to drop out a funnel cloud or a tornado. Just because you get a wall cloud doesn't mean you're going to get a tornado, right? Sometimes you get a wall cloud, it starts rotating, and the whole thing falls apart for whatever reason. Okay? Doesn't mean you're going to get one. Just because most mornings you come out of your house and turn right, doesn't mean every time you come out of your house you're going to turn right. Maybe you'll turn left today. So the difference between a shelf cloud and a wall cloud. A shelf cloud, remember we said, is under the rain area, where it's raining, that's where your shelf cloud forms, and then it races out ahead of the thunderstorm, like in the video I showed you. Your wind is going to change direction, going to pick up in speed. A wall cloud, on the other hand, is under the area that it's not raining, the rain-free base. It's going to move with the thunderstorm. It's not going to move out from under the thunderstorm. It's going to move with it. The shelf cloud is where air is flowing down and out. It's pushing that shelf cloud out over you, ahead of the thunderstorm. A wall cloud is where the air is flowing in and up. So to a large extent, they're opposites, right? Shelf cloud, down and out. Wall cloud, in and up. Shelf cloud, where it's raining, downdraft. Wall cloud, where it's not raining, updraft. Shelf cloud, race out ahead of the thunderstorm. Wall cloud, stays under the thunderstorm. Shelf cloud, I need to be worried about wind. Wall cloud, I need to be worried about a tornado. Dickinson, even Gustafson, 3 years ago, never produced a tornado. Never produced a tornado. But boy, I'm telling you, every possible thing was there that the very next step was to get a tornado, and it just did not. You know, your child is on the verge of tipping your, but for some reason they just didn't today. They kind of backed down. You don't need to put them in timeout. West Hope, 4 miles northeast of West Hope, Bonneville County last year. Here's what the radar showed. Here's our return, right? Our rain, maybe some hail in there and so on.
Thank you for watching. Continued in Part 8. Videographed by Matthew Kronberger. If you enjoyed the presentation, comment and subscribe to my YouTube channel at Matthew Kronberger, Bismarck, North Dakota.